According to the National Electrical Code, it is legal to use 100 amp sub-feed cable in an industrial setting without running it in conduit under certain conditions. Here are the allowable conditions for open installation. Firstly, consider the location. The cable must be installed in a dry, ventilated location where it will not be exposed to physical damage or chemicals. Secondly, consider the height. The cable must be installed at least 10 feet above the floor or working surface. Thirdly, motorized equipment must be considered. The area where the cable is installed must not be accessible by motorized equipment. Fourthly, avoid drop ceilings or water. The cable must not be installed over drop ceilings or in areas where it could come into contact with water. Consider the cable requirements. The cable must be type MC, or SEU cable rated for 100 amps. The cable must be properly supported with cable trays or straps to prevent it from sagging or being damaged. Also, consider additional precautions. Install cable guards or barriers to prevent accidental contact or damage. Use appropriate cable connectors and terminations to ensure a secure and safe connection. Regularly inspect the cable for any signs of damage or deterioration. It is important to consult with a qualified electrician to ensure compliance with the NEC and any local codes and regulations. When installing electrical equipment, it is always important to understand relevant codes and regulations. This is especially true when dealing with high amperage circuits. If you are unsure about any aspect of the installation, it is always best to consult with a qualified electrician. Type MC cable, or metal-clad cable, consists of insulated conductors encased in a metallic sheath. This sheath provides excellent protection against physical damage, making MC cable a popular choice for exposed installations in industrial settings. Type MI cable, or mineral insulated cable, features conductors insulated with a mineral compound, typically magnesium oxide, and encased in a seamless metallic sheath. MI cable offers exceptional resistance to heat, fire, and corrosion, making it suitable for harsh environments. Type SEU cable, or service entrance cable, is commonly used to connect the utility power supply to a building's main service panel. While primarily intended for service entrances, SEU cable can also be used for subfeeds in certain applications, provided it meets the relevant code requirements. When selecting cable trays or straps for supporting the cable, ensure they are appropriately sized and rated to handle the weight and size of the cable. Proper support prevents sagging, which can strain the conductors and insulation, leading to premature failure. Cable guards and barriers provide an additional layer of protection against accidental contact or damage from equipment or personnel. They are particularly important in areas where the cable is exposed or accessible. Ensure that the cable connectors and terminations are compatible with the type and size of cable being used. Use appropriate tools and techniques to create secure and reliable connections. Loose or poorly made connections can cause overheating, arcing, and even fire hazards. Regular inspections are crucial for identifying any signs of damage, deterioration, or loose connections. Look for cracks, abrasions, or discoloration in the cable insulation. Check for corrosion or oxidation at the connections. If any issues are found, address them promptly to prevent further damage or safety hazards. In addition to the NEC, local codes and regulations may impose additional requirements or restrictions on electrical installations. These codes may vary depending on the jurisdiction and the specific type of occupancy. It is essential to be aware of and comply with all applicable codes and regulations. Consulting with a qualified electrician ensures that the installation is performed safely, correctly, and in accordance with all relevant codes and regulations. A qualified electrician has the knowledge, experience, and training to assess the specific requirements of the installation and to recommend the appropriate materials and methods. They can also perform the installation in a manner that minimizes the risk of electrical hazards. Always prioritize safety when working with electricity. Electricity can be dangerous, and improper installation or maintenance can lead to serious injury or even death. If you are not comfortable working with electricity, always hire a qualified electrician. Even if you are experienced with electrical work, It is always a good idea to consult with a qualified electrician before undertaking any major project. They can provide valuable advice and guidance, and they can help you avoid costly mistakes. The NEC provides a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. The NEC is not law, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Familiarizing yourself with the NEC is essential for anyone involved in electrical work. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial. The NEC is a complex document, but it is well organized and easy to navigate. It is divided into chapters, articles, and sections, each of which covers a specific topic. The NEC also includes numerous tables and examples to help clarify the requirements. You can purchase a copy of the NEC from the National Fire Protection Association (NFPA). You can also find the NEC online at the NFPA website. In addition to the NEC, there are many other resources available to help you learn about electrical safety. These resources include books, articles, websites, and training courses. The NFPA offers a variety of training courses on electrical safety. These courses are designed for electricians, engineers, inspectors, and other professionals who work with electricity. The Independent Electrical Contractors IEC also offers a variety of training courses on electrical safety. These courses are designed for apprentices, journeymen, and master electricians. There are many online resources available to help you learn about electrical safety. The Electrical Safety Foundation International (ESFI) website offers a wealth of information on electrical safety. The Occupational Safety and Health Administration (OSHA) website also offers information on electrical safety in the workplace. Electricity is an essential part of modern life, but it can also be dangerous. By following the safety guidelines and consulting with qualified professionals, you can minimize the risks and ensure that your electrical installations are safe and reliable. Remember, when dealing with electrical installations, consulting a qualified electrician is not just recommended, it's a crucial step to ensure safety and compliance with the relevant codes and regulations. A licensed electrician brings a wealth of knowledge and experience to the table, ensuring that all aspects of the installation, from cable selection to termination techniques, meet the required standards. The NEC is a living document, constantly evolving to incorporate new technologies and address emerging safety concerns. Staying up to date with the latest revisions of the code is essential for anyone involved in electrical work. Changes to the NEC can have a significant impact on installation practices, so it is important to understand the implications of these changes. Subfeed cables are commonly used to supply power to subpanels or other remote locations within a building. These cables must be properly sized and installed to ensure that they can safely carry the required current. The size of the subfeed cable is determined by the load it will be serving, as well as the length of the run. Longer runs require larger cables to compensate for voltage drop. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC specifies the maximum allowable voltage drop for different types of circuits. The ampacity of a cable is the maximum amount of current it can safely carry. The ampacity of a cable is determined by its size, insulation type, and installation conditions. The NEC provides tables that list the ampacity of different types of cables under various conditions. When selecting a subfeed cable, it is important to choose a cable with an ampacity that is sufficient to carry the load it will be serving. It is also important to consider the voltage drop and to select a cable that is large enough to minimize voltage drop. Grounding is an essential safety measure that helps to protect against electrical shock. Grounding provides a low resistance path for fault current to flow back to the source, which causes the circuit breaker to trip and de-energize the circuit. All electrical equipment must be properly grounded. The grounding system must be installed in accordance with the NEC. Overcurrent protection is another essential safety measure that helps to protect against electrical fires and equipment damage. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip or blow when the current exceeds a safe level. All electrical circuits must be protected by overcurrent protection devices. The overcurrent protection devices must be sized and installed in accordance with the NEC. When working with electricity, it is important to wear appropriate personal protective equipment (PPE). PPE includes safety glasses, gloves, and footwear. Safety glasses protect your eyes from flying debris. Gloves protect your hands from electrical shock and burns. Footwear protects your feet from electrical shock and falling objects. It is also important to use insulated tools when working with electricity. Insulated tools help to protect you from electrical shock. Before working on any electrical equipment, always de-energize the circuit. De-energizing the circuit means turning off the power at the circuit breaker or fuse box. Always test the circuit to make sure it is de-energized before working on it. Use a voltage tester to test the circuit. A voltage tester is a device that indicates whether or not there is voltage present in a circuit. If the voltage tester indicates that there is voltage present, do not work on the circuit. If the voltage tester indicates that there is no voltage present, you can proceed to work on the circuit. However, always exercise caution and double-check to make sure the circuit is de-energized. Always follow the manufacturer's instructions when installing or working on electrical equipment. The manufacturer's instructions provide important information about the proper installation and operation of the equipment. Failure to follow the manufacturer's instructions can result in electrical shock, fire, or equipment damage. If you are not comfortable working with electricity, always hire a qualified electrician. A qualified electrician has the knowledge, experience, and training to perform electrical work safely and correctly. Working with electricity can be dangerous, so it is important to take the necessary precautions. By following the safety guidelines and consulting with qualified professionals, you can minimize the risks and ensure that your electrical installations are safe and reliable. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other qualified professional before undertaking any electrical work. Remember, electrical safety is paramount. Prioritize safety in every step from planning to execution to ensure a safe and compliant electrical installation. The NEC is a comprehensive and detailed document that provides guidance on all aspects of electrical installations. It is important to consult the NEC for specific requirements related to your particular installation. The NEC is available for purchase from the National Fire Protection Association (NFPA). It is also available online at the NFPA website. Understanding and adhering to the NEC is essential for ensuring the safety and reliability of electrical installations. A thorough understanding of the code, combined with practical experience and a commitment to safety, is the foundation of sound electrical work. Always prioritize safety when working with electricity. Electricity can be dangerous, and improper installation or maintenance can lead to serious injury or even death. If you are not comfortable working with electricity, always hire a qualified electrician. Even if you are experienced with electrical work, it is always a good idea to consult with a qualified electrician before undertaking any major project. They can provide valuable advice and guidance, and they can help you avoid costly mistakes. Electrical codes and regulations are constantly evolving to reflect changes in technology and best practices. Staying up to date with the latest revisions of the code is essential for anyone involved in electrical work. The NEC is updated every 3 years, and local codes may be updated more frequently. It is important to be aware of any changes to the code that may affect your work. Sub-feed cables are an important part of many electrical systems. They provide a reliable and safe way to supply power to remote locations within a building. When installing sub-feed cables, it is important to follow the NEC and all applicable local codes. It is also important to use high-quality materials and to install the cables in a workmanlike manner. By following these guidelines, you can ensure that your sub-feed cables will provide years of reliable service. Proper support of the cable is critical to prevent strain on the conductors and insulation, which can lead to premature failure. Cable trays, straps, or other approved supports must be used to secure the cable at appropriate intervals. The spacing between supports will depend on the type and size of the cable, as well as the installation environment. The NEC specifies the maximum allowable spacing for different types of cables. In addition to providing physical support, cable supports also help to prevent the cable from rubbing against other objects, which can damage the insulation. When selecting cable supports, it is important to choose supports that are compatible with the type and size of cable being used. It is also important to choose supports that are suitable for the installation environment. For example, in corrosive environments, it is important to use cable supports that are made from corrosion-resistant materials. Proper termination of the cable is essential for ensuring a safe and reliable connection. Cable terminations must be made using approved connectors and methods. The connectors must be properly sized for the cable and must be installed according to the manufacturer's instructions. When making cable terminations, it is important to ensure that the conductors are properly stripped and that the connections are tight. These connections can cause overheating, arcing, and even fire. It is also important to ensure that the cable insulation is not damaged during the termination process. Damaged insulation can lead to electrical shock and short circuits. After the cable is installed and terminated, it is important to test the insulation to ensure that it is working properly. The testing should include a visual inspection to check for any damage or defects, as well as electrical tests to verify the continuity, insulation resistance, and grounding of the circuit. If any problems are found during the testing, they should be corrected before the circuit is put into service. Regular maintenance is essential for ensuring the long-term reliability and safety of electrical installations. The maintenance should include periodic inspections to check for any damage, deterioration, or loose connections. It should also include testing of the circuit to verify its performance. Any problems that are found during the maintenance should be corrected promptly. By following a regular maintenance schedule, you can help to prevent electrical failures and ensure the safety of your electrical installations. The importance of adhering to electrical codes cannot be overstated. These codes are in place to protect people and property from electrical hazards. Failure to comply with electrical codes can result in serious injury, death, or property damage. Electrical codes are constantly evolving to reflect changes in technology and best practices. It is important to stay up to date with the latest revisions of the code to ensure that your electrical installations are safe and compliant. If you are not familiar with electrical codes, it is important to consult with a qualified electrician before undertaking any electrical work. A qualified electrician can help you to understand the codes and to ensure that your electrical installations are safe and compliant. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always take the necessary precautions to protect yourself and others from electrical hazards.